Okay, now let's look at how to filter out missing values. Suppose, let's assume that you've decided, okay, I'm not going to impute values for the missing values, I just want to get rid of them. Okay. If you want to do that, okay, you have to be very careful. That's not a good idea in most cases. Okay. But let's just say that this is one of those rare cases where you want to get rid of them. So how do you do that? So drop NA is the method that we can use. So if you take str data drop NA, okay, so now it's dropped the missing values. Now drop NA works about the same with data frame. So now I'm going to create a data frame, okay, and I want to make it easy to type. So data equal to PD data frame, right? Okay, and I want to give a list of lists. Okay. I want to give a list of 1, 6.5, 3, and the second list I want to give 1 and missing value. Okay. Now to make it easy, the missing value comes from NumPy. Okay. So I want to just type NA instead of typing np.nan. So if you type np.nan, so that would be missing value. So to make it easier to type, what we can do is instead of having to type np, which is the nickname we have given to NumPy, we can go inside NumPy and then give a nickname to any particular method that's available in the module, in the library. Okay, right now, to access any of the functionality in NumPy, you have to start with np dot whatever method you want, right? Okay, so but you want that np.nan to come in NAN, the NAN functionality, you want a nickname for that. So we can say from NumPy, okay, import nan as NA. So now we are giving a nickname to that function NAN. So I don't have to type in np.nan, which will work too, because once you say np, so this is coming from np, and then take nan. Now that has a nickname na, so simply saying na is same as np.nan. Okay. So now we can say na 3 NAs, and then NA 6.5 and 3. Okay, the data frame is with an uppercase D. Okay, so now if you say okay, data, So you take the data and then you say drop NA, right? Now what that's going to do, the default is how many missing values should a row have for you to drop, and the default is 1. So if one or more missing value, if a row contains one or more missing value, then that entire row gets dropped. So that means only the first row survives. The others have one or more missing values. Okay. So which is like saying, so drop NA is same as saying how is any. Okay, that's the default. That's the same as that. Okay. Now if you say all, right? So instead of any, you say all, then rows will be dropped only if all of them are NaN. Okay. If you have just even one good value, it's retained. Okay. Now what if you want something in between? Okay. Instead of having just one or all, something in between, then that's called threshold. You can specify that with data drop NA thresh equal to say 2 or 3, all. Okay, let's say 2. Okay, so now this okay, let's go back to, yeah, see this one is dropped because there are 2, this one is dropped because there is 3. Now this one is dropped, the last one is not dropped because it has only 1. And you can use axis to drop column instead of rows. So we have data drop NA axis equal to 1. Okay. So we look at each column, and once again the default is any. So even if one value is missing, then it'll be dropped. Okay, so let's let me. So you see that each column has at least one NaN, and of course you have the drop NA how is all, and axis equal to 1. Okay, so it doesn't drop anything at all because none of the columns are all missing. Okay. We just did threshold up here, so I'll just move that down. Okay. Now you can also specify the columns that must be looked at. Okay. So we can say data drop NA and then say subset, and say we want to look at only zero and 2. Okay. So that's our subset, and that should be in a list. So I have to put that in like that. Okay. And then say how equal to let's say all. So now you'll look at okay, so these are numbers, so I shouldn't. All right. So you'll now look at column 0 and column 1, so I have to say x is equal to 1. Okay, so what happened here? Subset 0, 2, x is equal to 1, 0, 2, all. So x is equal to 0, then we have 0 and 2. Okay, so x is equal to 0 and 2. Okay, x is equal to 0 and 2, then it looks at rows. So each row, you'll only look at this column and this column, right? So when you say all, okay, both must be NaN. So 0 is not thrown out, 1 is not thrown out because not all are NaN, but 2 is thrown out because they're all. Between 0 and 2, they both are NaN.